Okay, in question 11, express the power of 100 watt bulb in CGS unit. So we have given power as 100 watt. तो इसको हम लिख सकते हैं watt basically is your joules per second. So this thing can be written as 100 into 1 joule upon 1 second. So CGS में your joule basically it is ergs, और एंड 1 जूल यू कैन फाइंड आउट. अगर आपको अर्ग्स में नहीं पता कि इसको कैसे कन्वर्ट करना है तो फर्स्ट ऑफ ऑल हम इसको अर्ग्स में चेंज करते हैं. अर्ग्स बेसिकली इट इज़ द CGS यूनिट ऑफ जूल्स. सो यहाँ पर इट विल बी इक्वल्स टू 1 किलोग्राम मीटर पर सेकेंड स्क्वायर, मीटर स्क्वायर पर सेकेंड स्क्वायर. सो it will be 10 raised power 3 grams into 10 raised power 2 meter square second raised power minus 2. So it comes out to be 10 raised power 3 plus 4 gram meter square second raised power minus 2. So it will be 10 raised power 7 and it comes out to be ergs. So 1 joule is equivalent to 10 raised power 7 ergs. तो यहाँ पर अगर हम सब्सटीट्यूट करते हैं so it will be 10 raised to power 9 ergs per second. So this is the answer. In question number 12, the normal duration of some physics practical period in Indian colleges is 100 minutes. Express this period in microcenturies, and 1 microcentury is given as 10 raised to power minus 6 into 100 years. Okay, your century basically 100 years hota hai and micro is 10 raised to power minus 6. So how many microcenturies did you sleep yesterday? So what we have given like the period is basically 100 minutes long, and what we have given 1 microcentury is equals to 10 raised to power minus 6 into 100 years. Okay, so first of all let me convert 1 microcentury into minutes. Okay, how many minutes are there in 1 microcenturies? So it will be 10 raised to power minus 4, and then in 1 year, and इसको हम ऐसा लिख सकते हैं 1 year. So 10 raised to power minus 4, 365 days and 24 hours per day into 60 minutes. तो ये तो आ गया हमारे पास योर माइक्रो सेंचुरी इन मिनट्स. ओके, जब इसको सॉल्व करते हैं सो इट कम्स आउट टू बी 52.56 minutes. So in 1 microcenturies there are इतने minutes. So in 1 minute, now I can apply unitary method. In 1 minute there will be 1 upon 52.56 microcenturies, and in 100 minutes there will be 100 divided by 52.56 microcenturies. So when you solve this, it comes out to be 1.9 microcenturies. Okay, so the normal duration of the practical period will be nearly 1.9 microcenturies. So in the second part, how many microcenturies did you sleep yesterday? So let sleeping time be, हम कुछ ले लेते हैं 300 minutes ले लेते हैं. So 100 minutes corresponds to that many microcenturies. तो आपका माइक्रो सेंचुरीज में हो जाएगा 3 into 1.9 microcenturies, and it comes out to be 5.7 microcenturies. Okay. In question number 13, the surface tension of water is 72 dyne per centimeter. Convert it in SI unit. So surface tension, say S, is given as 72 dyne per centimeter, and we have to convert it into SI unit. So we know that 1 Newton is equals to 10 raised per 5 dyne. अगर नहीं पता है, still we can find out this relation. So 72 into 1 dyne divided by 1 centimeter. So 1 dyne is equals to 10 raised per minus 5 Newton. So 72 into 10 raised per minus 5 Newton. And 1 centimeter can be written as 10 raised per minus 2 meter. So it comes out to be 0.072 Newton per meter. In question number 14, the kinetic energy K of a rotating body depends on its moment of inertia I and its angular velocity omega. Assuming the relation to be K equals to some constant times I raised per A omega raised per B, where K is a dimensionless constant, find A and B, where moment of inertia of the sphere about its diameter is 2/5 mr square. So यहाँ पर we have to apply dimensional analysis to find out the relation of kinetic energy in terms of moment of inertia and angular speed. So first of all, we should know what are the dimensions of kinetic energy. So kinetic energy, so energy की dimension होती है आपकी m raised to power 1, l raised to power 2, t raised to power minus 2, and the moment of inertia, that is given to us as 2/5 mr square. 2/5 is a dimensionless constant, so it will be m raised to power 1, and r is distance, l raised to power 2. So this is the dimension of I, and the dimension of angular speed is t raised to power minus 1, and the formula is given as, okay, so if we take dimension on both sides, so here we have m raised to power 1, l raised to power 2, t raised to power minus 2. K is a dimensionless constant, तो ये तो कुछ contribute नहीं करेगा. So I is given as m raised to power 1, l raised to power 2, and whole raised to power a, and it is t raised to power 1 whole raised to power b. So it comes out to be m raised to power a, l raised to power 2a, t raised to power minus b. So now we have to compare left hand and the right hand. So from here, your a comes out to be 1, and in the second, from L, 2a comes out to be 2, and your minus b is equals to minus 2. So from here, a is equals to 1 and b is equals to 2. So these are the values of a and b, और वही हमें निकालना. So in question number 15, theory of relativity reveals that mass can be converted into energy, and the energy E so obtained is proportional to the certain powers of the mass and the speed of light c. Guess a relation among the quantities using the method of dimensions. So we have given like E is proportional to sum of the power of your mass, say alpha, and E is also proportional to some power of the speed of light, say that is beta. So we can say E is directly proportional to m raised to power alpha, c raised to power beta. So we can apply some dimensionless constant here. So it becomes m raised to power alpha c raised to power beta. So now we'll take dimension on both sides. So it will be dimension of E. So dimension of K m alpha c raised to power beta. So dimension of energy will be m raised to power 1, L raised to power 2, T raised to power minus 2. Here dimension of K and then m raised to power 1 alpha. Speed of light is L raised to power 1, T raised to power minus 1 raised to power beta. So here this will not contribute anything because it is a dimensionless constant. So it will be m raised to power alpha, L raised to power beta, T raised to power minus beta. So now we have to compare the left hand side and the right hand side. So the dimension को compare करते हैं. So the alpha comes out to be 1, beta comes out to be 2, and so from here minus beta equals to minus 2, वही same आपको मिल गया, beta equals to 2. So the relation will be some k m raised to power 1 and c raised to power 2. Okay, or experimentally it is found that the value of k is 1. So the relation is E is equals to mc square, the famous equation of Einstein. Okay, thank you.